Hey guys! It's Thalia from Thompson STEM Engagement here, and it's that time of the year again. It's my birthday! Happy birthday to me! But it got me thinking, time. What even is time? Another lap around the sun? The time it takes for the germination of a flowering shoot of a plant to emerge from the soil and face the light? A measured unit of spatial distance? Time is a concept that has captured the hearts and minds of philosophers, scientists and artists alike. From the surreal works of Salvador Dali and his figurative representations of the futility and atrophy of time and the persistence of memory, to Plato's understanding of time as the wandering of these bodies in their movement, and not a kind of number that measures such movement. Ravelli was similarly of a belief that time is an illusion, but despite our differences in individual understandings of time, I think that it can be agreed that time is one of the most difficult and fascinating properties of the universe. So, without further ado, it's time for the intro. You're probably familiar with the basic units of time that we use to measure our years, days, hours and minutes. This is how we experience time, and this can be described by these basic incremental measurements that we've attributed to it. This is our personal time. However, this is not what time is. Time is much more vast and complex than this. Our modern understanding of time didn't come until the early 20th century. Quantum mechanics played a strong role in the revolution of physics and understanding of time, with pioneers like Einstein and his famous theory of relativity creating the foundations for time as we know it. Thanks, Einstein. But if he is correct about time, then this world is definitely a lot stranger than meets the eye. According to the theory of relativity, there's room to explain the existence of events such as time dilation for fast-moving objects or objects affected by extremely strong gravitational pulls. This theory also provides evidence that suggests the prospect of time travel can be real. And for a sci-fi nerd like me, this is a dream to hold on to. And I know what some of you are thinking, isn't that science fiction? That's science fun. There's several hypothetical scenarios that actually support this concept. However, this suggests an eventual emergence of, well, paradoxes, and this is something that's questioned amongst the scientific community, but it's yet to be agreed on. I still think it's safe to say that time is definitely one of the universe's most mysterious properties. What even is time? Does it even exist? When did it start? And does a beginning of time imply an end? And I know this whole time travel stuff. I know. It turns out time is not as linear as we thought, eh? So many questions. Well, to start off with, yes, time does have a beginning. Some 13.7 billion years ago, in conjunction with the Big Bang. So technically it is also believed that there is an end, but don't panic. Scientists believe this is in approximately 5 billion years, so you got plenty of time. Anyways, back to Einstein's theory of relativity. The theory of relativity describes time as a fluid construct, like a river meandering, twisting, forking, pooling. And as such, the emergence of split timelines and time travel is really a concept that must be taken seriously. Before this, the Newtonian understanding of time described it as moving in a much more linear fashion, opposed to the model that we now know. Time and space are intricately woven together like the fabric of a cloth, and similarly to fabric rips can form within the space-time continuum and give rise to such events. Einstein's math provides us with this foundational basis and a blueprint to begin designs for such time travel tools. And such designs have indeed been made. And as exciting as this isn't a practical feat within today's society. The expected energy needed to run a time machine is greater than any atomic bomb we've ever created. And to give you an idea of how much energy we're actually talking about here, yeah, that's a lot. But presuming that we were to achieve this, however, that raises a whole new set of questions. as to the paradoxes that could be created by actions in the past that we made that could change our future. The many worlds theory of quantum mechanics tends to lead towards a general understanding that time has this ability to fork, and the generation of multiple different timelines are possible within our own universe, and if we were to go back in time and change defining factors from the past, in essence, we would be going back in time and we would create paradoxes and parallels to our own universe. For example, if you were to go back in time and kill Hitler before the war, you would be going back and killing another Hitler, genetically identical to the Hitler from our own timeline, but that Hitler would survive and continue to commit the atrocities that he did. Anyways, it's been attempted by scientists like Hawkins to disprove this eventuality, but this is yet to be established. And as such, parallel universes is a theory that's still very much alive. And to be honest, I find that kind of terrifying. Every single decision that you make has potential to give rise to an alternate reality in which that didn't happen. Somewhere out there, there's a me that didn't decide to wear this topping today. Hi. And one that decided to wear a hat. Or wear shades. And yeah, it goes on and on and on and whoa, that's enough of that. Anyways, time is such a fascinating concept. From our third-dimensional interaction with time, in comparison to the nature of space-time and multidimensional time. Different cultures and societies are even established that run off different measurements of time, going off lunar calendars. An example of this can be seen in Ethiopia, where the calendar is comprised of 13 months and is 7 years behind the Georgian calendar that we use. It's currently 2014 there. I think I can see where philosopher Ravelli was coming from when he said that time was an illusion. I guess the time that we experience is an illusion of some sort, as it's most definitely more than it seems at first glance. Our lives are ruled and dictated by time in so many ways, from our work and personal lives, to the 24-hour circadian rhythms that regulate our sleep, to the lunar-led menstruation cycles experienced by women like me. We can't escape time, and we can try our best to measure and understand it, but how much do we really understand about time? It might have been one more lap round the sun for me. So here's to another great year. I wonder what will happen in all of that time. Be sure to join us next time, and please ask any questions you might have in the comments section below. Anyways, it looks like we've ran out of time. Stay focused, stay curious, stay questioning, and study STEM. Thanks again guys for joining us here at Thompson STEM Engagement. Till next time, don't forget to like, comment, subscribe, and carry on learning.